So good afternoon, students, and welcome to the summer course. So this is your, physics class, second physics class. I am Sunit Kumar, your physics teacher. So I'll be continuing with force and pressure, the second lecture of force and pressure. So let's start the class, students. So force and pressure, this is what we started in the previous lecture. And we all saw that what was the prerequisite. So you should know the basic mathematics where you do simple addition, subtraction, multiplication, and division. You should also know the definition of force, which we did in the previous class, that push or pull is called force, any form of push or pull. And we also saw that force is due to an interaction between two objects. So this is what we did in the previous class, that whenever there is an interaction between two objects, so force is being applied from one object on the other. So the weightage of this chapter, as I told you in the last class as well, is 6 to 8 marks. So there are 6 to 8 marks question which comes from this particular chapter in your annual exams. So today what we are going to cover is the effects of forces and the types of forces. So we discussed that in today's class we are going to do these particular subtopics. So effect of forces and types of forces. So let's start with effects of forces, student. So can we see the force? We cannot see a force, right? So we can only experience the force, right? So force cannot be seen, but how do we come to know that whether there is force or not? By its effect. We see the effect of the force. So let's say we are pushing something and the body starts moving. So that is the effect of the force. When a body is moving, we try to stop it. So once it stops, we get to know that we have applied some force. So whenever there is an effect, right, with that effect, you get to know whether the force is being applied or not. Clear, students? So we saw that effects of forces, there were few effects of forces. First effect is that a body at rest can be made to move when we apply a force. So when the ball is kicked here, the ball starts moving, right? So this is one effect of force. A body which is at rest, an object which is at rest, it can be made to move by applying a force. The second effect, so force here, which is in the form of a kick, is used to change the state of the object, that is ball, from rest to motion. Now, second effect, if you see, as I discussed, if there is a body already moving, it can be brought to rest again by application of a force. So, for example, a fielder catches a ball near the boundary. So the ball is caught by the fielder. So here the ball was moving and it came to rest when the fielder, caught it, right? So here the motion, a body in motion has been brought to rest. This is another effect of force. So force here is what the fielder is applying to catch the ball, is used to change the state of the body, that is from motion to rest. Okay. Now, another third effect of force is change in speed. So let's say a body was already moving and we start pushing it in the same direction in which it is moving. Then the speed of the body will increase. So here the speed has changed. It has increased due to the application of force. This is third effect of force. It can happen opposite as well. If a body was moving and if I start applying a force in opposite direction, then here the speed will decrease. So here in this case, the change in speed is there, but it is decreasing. So change in speed can be increasing, can be decreasing. So this is the third effect of force. So here we see that when we drive a car, by stepping on the brakes or by stepping on the accelerator, the speed changes. When we apply brakes, the speed decreases, and when we apply accelerator, when we push the accelerator pedal, the speed increases. Okay. So if the force is applied in the direction of motion, of the object, its speed increase. So when you apply a force in the same direction in which the object was moving, then the speed will increase. And if you apply the force in an opposite direction in which the body was moving, the speed is going to decrease. So this is another effect of force, that is change in speed. So force with what is the force which is being applied here? The brakes or the accelerator is used to change the speed here. Now the fourth effect, if you see, the change in direction. So if a body was already moving, the direction can be changed by applying a force, right? So for example, if we take an example of cricket or baseball, when the ball is being hit by the batsman or the player in the baseball, the direction of the ball changes. So this is another effect of force. The player, when hits the ball, it changes the direction. So this is next effect of force. So what is the force here? The force is in the form of hit, which is used to change the direction of the ball here, right? Now another effect of force is change in shape. So I'll summarize all these effects as well. So let us first understand all these effects one by one. So change in shape. So how does the shape change? Okay, just let me check. Why is this happening? Just give me a moment, okay? Students, we are checking from the backend. I have asked someone to check it. So if you have been removed from the meeting, please rejoin. And then I have asked the support team to check it and will be there attentive if someone is doing by mistake, by mischief.
Sir, I was also removed from the meeting.
Sir, me too, sir.
Yeah, I got to know by reading your chats. So I have asked someone from the support team to check it why this has been done, and there will be someone who will be there in the meeting to check if if someone is doing a mischief here. So please, someone, if you are doing it purposefully, please don't do this, right? It's not good. So let everyone join the class and let everyone attend the class and learn, and please don't create a disturbance here. Okay. Yeah, so we were talking about change in shape, another effect of force. So when we apply a force, right, the shape of the object can change, right? For example, so you see this rubber band. So when you pull the rubber band, what do you observe? The shape of that is being changed. It gets elongated, right? So rubber band is stretched. This is another example of effects of force. So change in shape. So what force is being applied here? The stretch is the force which is applied to change the shape here, right? And if we summarize each of these, so we saw all of these effects of forces. First effect was that the force applied on a body which is at rest, the body starts moving. The force, when it is applied on a moving object, it may come to rest. When a force is applied, the speed may change. You can increase the speed or decrease the speed by applying the force. You can change the direction of motion by applying the force, and also you can change the shape of the body by applying force. So these are the 5 effects of forces which we just saw. So a body at rest can be made to move by applying force. This is one effect of force. Second, a moving body can be brought to rest. This is second effect of force. There can be a change in speed which can be made. This is third effect of force. Change in direction is the fourth effect of force, and change in shape is the fifth effect of force. Okay, so let's go ahead, student. So I'll summarize each of these. You can take a note of this in your notebook as well. So what are the effects of force? First, a force can move a stationary object, right? A body at rest. Second, a force can stop a moving object. This is second effect of force. Third, a force can change the speed of the moving body. It can increase the speed, it can decrease the speed. Fourth, a force can change the direction of moving object. And fifth is a force can change the shape and size of an object. So these are the 5 effects of forces. So students, please write it down in your notebook, because this comes in exam. What are the effects of forces? So you will write down. So if they have asked you write down 2 effects of forces or 3 effects of forces, you can write any 2 or any 3 out of these 5. Please note it down. Okay. Have you all written it down? Shall we move ahead, students?
Sir, 1 minute, sir.
Yeah, please write it down. I'll wait for another 2 minutes. Are you all enjoying the summer courses? You can write down on the chat if you are enjoying the summer course, if you are liking the summer course or not. So are you liking the summer courses? Yeah. So it will give you, an edge over others when you join back schools. You will be way ahead than them. You would have revised the whole concept, and parents would be also happy that you are studying for 3 hours and then you are playing for the whole day. So it's a balance of both, right? Isn't it? Okay, students. So I hope you have written it down, students. Let's move to the next topic.
Sir, can you just
Okay.
wait?
Okay. Yeah. Please. I'll just wait for 1 or 2 more minutes. Shall I go ahead, students? You can give me a thumbs up once you've written it down. Great. Okay, let's move ahead, students. Now, let's talk about types of forces. So there are 2 types of forces. One is contact force and other is non-contact force. Okay, so there are 2 types of forces. One is contact force and other is non-contact force. The name itself tells you that contact force, for this kind of force to act, the body which are interacting, they have to be in contact with each other for this force to be applied. So example of contact force can be friction force. Any kind of push or pull is again a contact force, right? Now, another type of force is non-contact force. So these forces, you don't require to be in contact with the other object. For example, magnetic force, the magnets need not be in contact with each other. Magnet will apply a attraction or repulsion on another magnet even from a distance without being in contact. So magnetic force, electrostatic force, gravitational force, these are example of non-contact forces. For contact forces, it is friction, it is push or pull. These are examples of contact forces. So let's understand, a force which acts through a direct contact of object is called contact force. Example is muscular force and frictional force. So muscular force means any kind of push or pull which we are giving. If we are pulling something, if you are if you are, trying to lift something, these are all muscular forces because you are applying your muscular strength to do all these work, right? So first of all, you need to write there are two types of forces, right? So these are the two types of forces. One is contact force and other is non-contact force. Now, the definition of contact force is a force which acts through a direct contact of object is called contact force, right? There has to be a contact between the objects. And there are two examples of contact force. One is muscular force and other is frictional force. So as I said, in muscular force, any kind of push, pull, or lifting which you are doing, these are all examples of muscular force. Okay. And frictional force, we all know, is that when a body which is moving, so it comes to a stop all of itself, without applying. We don't see what kind of force is being applied here, but the body comes to rest eventually, and that is because of the frictional force. Okay. So you have to write this down. Two types of forces: contact force, non-contact force, definition of contact force, and example of contact forces. Have you written it down, students?
1 minute, sir.
Yep. When are the schools opening at Gateway International, students?
11.
11th. Okay. Shall we go ahead, students? Okay. Now, muscular force, if you see here, the example of muscular force. So can you push or lift book lying on a table without touching it? No, it is not possible. If you have to push this book or if you have to lift these books, you have to touch that book and then do that, right? So this is an example of contact force. That's why we say that it is a contact force. Muscular force is a contact force. The force exerted by the muscles of the body is called muscular force, right? What is muscular force? The definition of it is the force exerted by the muscles of the body is called muscular force. Okay? And it is an example of contact force. Clear, students? Now, this is another example of muscular force. So when you are trying to, take out water from the well, you are lifting that bucket, right, through the help of a pulley. So pulley is a simple machine which helps you do this work easily. Otherwise, it will be more tedious, right? So pulley helps you. So you are applying a muscular force to lift the bucket from the well to take out the water from the well, right? So can you lift a bucket of water without holding it? No, we cannot do it. We will have to hold it. We will have to have a contact with the rope so that you can pull it outside. You can pull water outside, right? So again, muscular force can be applied to an object only when our body is in contact with the object. And both these examples tells you that muscular force is a contact force. Let's move ahead, student. So the force resulting due to an action of muscles is known as muscular force, which we have already seen. Now, frictional force. So let's say when you stop pedaling, what happens? When you are pedaling a bicycle, so when you stop pedaling, what will happen? The bicycle will stop, and that is because of the frictional force. So when we stop pedaling a bicycle, it gradually slows down and finally comes to stop. Similarly, when we apply brakes, the car which is moving, it comes to a stop. So a car also comes to rest once its engine is switched off. So when you switch off the engine, what will happen? The car which was moving, it will eventually come to rest after some time, right? And these two phenomena happens because of the frictional force, right? So similarly, let's say a student, a boy has, kicked the ball. After some time, the ball will roll for some time and then it will come to a stop. Now, again, that is because of the frictional force. Okay. So the motion, the direction in which the motion happens, the friction is always opposite to that. So friction always opposes the motion. Okay. So we'll study more about this concept of friction in the next chapter. So the second chapter in your book is friction only. After force and pressure in physics, you have to study about friction. Okay. So friction is opposite to the direction of motion. Friction acts opposite in the direction of motion. Frictional force always opposes the motion of one body over another. So whenever there is a relative motion between two objects, between two bodies, friction will always act to oppose that relative motion. Relative motion means when this body is moving over this body towards, let's say, towards right, then the friction will be in opposite direction, that is towards left. Okay. So for example, let's say you have this block and you are applying a force here. So this makes the body move in this direction. So the friction will be in opposite direction, right? And let's say we are writing this friction force here. So friction is in opposite direction, which will oppose the motion. So if the motion is towards right, friction will be towards left, opposing this motion. Is it clear, students? Okay. So frictional force arises only when the surfaces of two objects are in contact with each other. Therefore, frictional force is an example of contact force. So because these objects, they touch each other, then only the friction force can be applied. So we say that friction force is an example of contact force. Clear? So we had seen contact force, a force which acts through a direct contact of object is called contact force, and examples are muscular force and frictional force. Now let's talk about non-contact force. What are non-contact force? From the name itself, you can understand it. A force which acts between two objects, even if they are not in contact, is called non-contact force. So even if two objects are not in contact, means if the interaction is not contact, then also this force can be applied. Such forces are called non-contact forces. Examples of non-contact forces are gravitational force. So when you drop something, let's say I'm dropping this pen. So when I drop this pen, what happens? That the earth pulls it towards itself, right? So this is an example of gravitational force, right? Earth pulling any object towards itself, right? So this gravitational force is without any contact. Earth is not in contact with this pen, but still this pen is falling down towards the earth. And that is an example of non-contact force, right? Second example of non-contact force is electrostatic force. We'll talk about this in further slides also. You must have observed that when you rub a balloon on your clothes, right? And then when you place it on the wall, the balloon is stuck on the wall. Have you done this kind of experiment, this kind of activity ever? Yeah, you have done it, right? And also when you rub the comb on your dry hair, and if there are bits of paper there, and when you bring that comb towards the bits of paper get attracted towards the comb. This is another example, right? Where you see this electrostatic force coming into action, right? So in these two examples, what we have seen that for electrostatic force to act, the bodies does not need to be in contact with each other, right? So electrostatic force is also an example of non-contact force. Third example of non-contact force is magnetic force. So as I said, if you bring two magnet poles together, right, even if they are not in contact with each other, when you bring them near, either it will attract or there will be a repulsion which will happen depending on whether the poles are like or unlike. If it is unlike pole, there will be attraction. If there are like poles coming near to each other, there will be a repulsion. Clear, student? Okay. So have you written down the definition of non-contact force and all the examples of non-contact force, students? Have you written down this definition of contact and non-contact force and the examples as well? Okay, good. Now, let's talk about all these non-contact forces one by one. So first was gravitational force. So gravitational force is a force which a body applies, one body having some mass applies on another body having some mass, right? So one example of gravitational force is the earth pulling everything towards itself, right? So you can see these apples falling down because of the gravitational force of the earth. So this is one example of gravitational force. So earth and apple was not in contact with each other. Still earth was applying a force, which is a non-contact force, right? Now objects get pulled towards earth due to the force of gravity. Okay, gravitational force is between any two objects having mass. But if there is a force of attraction between one body and second body being earth, so if earth attracts any body towards itself, that is called force of gravity. So gravitational force and gravity is different. If earth is involved, then we say it is gravity. If two objects other than earth are involved, then we say that it is a gravitational force. Is it clear? Yes, I'll show the previous slide. This one? Yeah, please write it down if you have not written. Once you write it, please. Okay, so I'll go ahead then. Yeah, we were talking about gravitational force and gravity. What is the difference between force of gravity and gravitational force? So gravitational force is between any two objects having masses. It can be, these two objects. So both these objects will apply a force of attraction. You are not able to observe them moving because the masses are very less, right? We'll talk about this in detail when we talk about gravitation. But you see the objects moving downwards towards the earth because the mass of the earth is very huge, and that's why the force is also very high, and that's why it pulls it down. So when the earth pulls any object towards itself, that force is called force of gravity. And when there is a force between any two objects, it is gravitational force in general. Okay, so one specific case when earth is pulling the body towards itself is force of gravity. Is it clear to everyone? Okay. Now let's move ahead. The pull exerted by objects possessing mass is called gravitational force. So any two objects pulling it, other object towards itself would be an example of gravitational force. Now remember, gravitational force is always a force of attraction. So there will be no repulsion here. So gravitational force is always attractive. So whenever there are two objects which are brought near to each other, which has some mass, they will attract each other. So gravitational force is always attractive. It is not repulsive, as in the case of electrostatic force and magnetic force. It can be attractive as well as repulsive, but gravitational force is always attractive. So gravitational force here also, the river flow is because of the gravitational force. So from a higher region, right? So from the hills and mountains, generally river flow downwards, right? So all of these river flow downward because of the gravitational pull of the earth. So water in rivers flow downward due to the force of gravity. The force with which the earth pulls the object towards it is called force of gravity. So force with which two objects attract each other is gravitational force, and force with which earth pulls an object towards itself is force of gravity. Is it clear, students? Have you understood the concept, the difference between gravitational force and force of gravity? Yes, I'll show the previous slide. This one? Chaitra?
Sir, the definition of gravitational force.
Okay.
Yeah.
I'll give you an example of both. Okay. Just in a while. Once he has written this, we'll
Yeah. Yes, sir.
done.
Thank you. Thanks.
Yeah. Okay.
Yes, sir.
So I'll talk about, what is difference between gravitational force and gravity. So example of that as well. Yeah. So when I say whenever there are two objects, let's say there is this object which has a mass m1 and there is this another object which has a mass m2, and let's say these two objects are having a distance of r between them. So they are separated by a distance r. So there will be a force of attraction between these two objects, okay, where this force of attraction is equal to g times m1 m2 over r square, right? Now, this is what you are going to study in class 9th in detail. You just need to understand that this force of gravity depends on the masses of the two objects, m1, m2. So when I'm multiplying the masses here, m1 into m2 means this force is dependent on these mass of two objects. One thing. Second, it is also dependent on the distance. If you increase the distance, the denominator will increase, and that's why the force will decrease. So if the bodies are far away from each other, the force of attraction will be less. If the bodies are near to each other, the force of attraction will be more, right? So any two objects, it can be these two balls. As I said, as I took an example, between these two pens, there will be a gravitational force. You are not observing it to move, right? You will say, ki, if there is a gravitational force of attraction, why are these two pens not moving? These two pens are not moving towards each other because the masses of these two pens are very less. The value of g, this constant, the value of this constant is generally very less, right? So that's why, so it is something of the form. So I'll write it here. G is equal to 6.67 10 to the power minus 12. So this is very small a value, 10 to the power minus 12, right? So if you multiply it with masses of, let's say, 1 kg and 2 kg, still this 10 to the power minus 12 will have an effect. So eventually, if you calculate it, the value of that force will be very less in the terms of 10 to the power minus 12 or 10 to the power minus 10, which is very less. So that's why you don't observe these two pens to move towards each other. Is it clear? Now, in the other case, if I take one of the object as Earth, for example, now when I take this object as Earth, now the mass of Earth is somewhere between 6 into 10 to the power 24 kgs, right? Now, if this is the mass of Earth, 10 to the power 24, now when you multiply it with 10 to the power minus 12, then also you have a force equal to 10 to the power 12 kind of thing, right? So that's why there, right? That's why that force is, you can observe that force, the gravitational force. Is it clear? Is it clear to students? Because the mass of Earth is very high, that's why the gravitational force due to Earth, you are able to feel that, you are able to observe that. But since the mass of these two pens are very less, and that's why the force is, you cannot see the effect of that force. Okay? Is it clear, students? Okay. So let's move ahead. Now, yeah. Now let's discuss electrostatic force. So the another force, that is electrostatic force. So electrostatic force again is an example of non-contact force. So as I said, when we rub a comb, right? So here what you can see is a glass rod and a silk cloth, right? So you have a glass rod and a silk cloth and bits of paper. So when you bring this glass rod or silk cloth near the bits of paper, the bits of paper does not get attracted. But when you rub this, so do you observe here anything? No. But when you rub this glass rod with this silk cloth, and then when you bring, so when you rub this glass rod with the silk cloth, the glass rod will get positively charged and this silk cloth will get negatively charged. So whenever you are rubbing two objects, so both these objects gets charged. How does this happen? We'll study this in later chapters. Okay. So now, when you rub a glass rod with this silk cloth, the glass rod becomes positively charged and silk cloth will get negatively charged. That is because of the transfer of electrons. Do you understand what electrons are? Students, do you understand electrons? Yeah. So when you rub an object, one object over other, what will happen? The object in which there are free electrons which are free to move, right? That electron, if the electron can be removed easily from an object, that electron will remove and go to the other object. So the object in which electron has gone, it will carry the negative charge with itself, right? So this will become negatively charged. Yes, yes, please say.
Sir, how can we identify that this can get positive and this can get negative charge?
Yes, so there are certain experiments which have been done, and using those experiments, we have a series of observations, right? So different objects, when rubbed with different object, what will happen? There is a table which has been formed, and that table is called triboelectric series. You can go today and do a Google search of triboelectric series. I'll just write it down for you. So this is triboelectric series. So in this series, what happens that, let's say you will have all these substances, all these objects or material written here, glass, silk, right? So in this series, whichever is above, right, becomes positively charged and whatever is below becomes negatively charged. So silk is below glass in that series, and that's how you get to know. And as a student, you get to know. As a scientist, what I'll do certain experiments. I'll see that what happens when I rub glass and silk, which one is positive, which one is negative. So that observation is being noted down, and then that's how we get to know which will be positive and which will be negative. There are experiments which say that this has become positively charged and this has become negatively charged. Is it clear? So in case of glass and silk, you need to remember that glass becomes positively charged and silk will become negatively charged. And it comes from this triboelectric series. Is it clear, student? Okay. So now, as I said, when we are rubbing this glass rod with this silk, what will happen? That glass rod has become positively charged and silk has become negatively charged. The glass rod, now when it is brought near the piece of paper, the glass rod attracts the piece of paper because it has a charge in it. And similarly, the silk cloth will also attract the bits of paper, again because it has charge in it. So because these bits of paper are neutral, right? So it will get attracted to both positive and negative. Why does that happen? We can do a detailed understanding of that in later sessions. But yeah, I'll just give you a hint also so that you understand it. Let's say this is this glass rod, right? Now it has a positive charge and these are these bits of paper. Now these bits of paper, because they are neutral, what will happen? All negative charge will get attracted towards this positive charge and positive charges will get repelled. What happens? You would have read this, that like charges repel each other and unlike charges attract each other? Have you read this? Have you gone through it in earlier classes? Have you gone through this in earlier classes, that like charges repel and unlike charges attract? Okay, so what will happen, that because unlike charges attract, negative charge come here and they attract these bits of paper, and these bits of paper get attracted towards this positive charge. In case of silk cloth, because this silk cloth is negatively charged, so what will happen to the bits of paper? All this positive charge will be attracted towards this, and that's why these bits of paper will get attracted towards it. Is it clear? Okay, students. So bits of paper get attracted again because of electrostatic force. So force exerted by a charged body on another body or uncharged body. So another charged or uncharged body is known as electrostatic force. So force exerted by a charged body on other body which is either charged or uncharged is called electrostatic force. Clear, students? You have understood it? Okay. So students, we will stop today for today's class. Magnetic force we are going to do in the next class, and we'll do these examples. So let us conclude today's lecture. So what did we study today is effects of forces and types of forces. One example of magnetic force, we'll take it in the next class, and the examples also in the
You're on mute, sir.
Sir, you are mute.
Okay, yeah. So we'll do these pressure and pressure exerted by liquid and gases in the next class. Okay. And so thank you, students. Thank you for joining in for today's class. So be regular in the classes. I'm sure you are enjoying these summer courses and you are getting benefited out of these. Be regular, study well, and do well in your exams whenever the school reopens. So all the best, student. Keep on studying. Thanks and bye. Take care.
Thank you, sir. Bye, sir.